Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. In the chapter of real numbers, we have studied Euclid's lemma by now, and we are thorough with the concept that if I divide a number by 3, the remainders can be 0, 1 or 2. If I divide a number by 2, remainders can be 0 or 1, right? So the remainder is always lesser than the divisor, and it can be greater than or equal to 0. And when is it equal to 0? When the divisor is a factor of the dividend, right? So this much we have already studied. Now we will talk about fundamental theorem of arithmetic. Fundamental theorem of arithmetic, right? If I give you any number, let us say if I give you a prime number like 19, okay, we are already aware of the concept of prime numbers and composite numbers. Prime numbers are such numbers which do not have a factor apart from itself and 1, okay, like 19. If I want to find the factors of 19, I can find only two factors, 19 into 1, right? 19 can be written as 19 into 1, okay. If for that matter take any other prime number, for example 23. 23 also has factors like 23 and 1, that's it, okay. So this is the case of prime numbers. And composite numbers are such numbers which have factors apart from itself and 1 also. For example, if I let us say take 24, okay, what are the factors of 24? 24, let us write 24 in terms of factor pairs, okay. 1 into 24, 2 into 12, 3 into 8, 4 into 6. So these are the factors of 24, 1, 2, 3, 4, 5, 6, 7, 8. So total 8 factors are there for 24, right? And 24 is a composite number. So it has got more than two factors, itself and 1. Apart from itself and 1, it has got 6 other factors. So it is a composite number. So every composite number can be factorized in prime factors, right? If I want to write this number in terms of its prime factors, how can I write it? What are the prime factors? 2, 3, right? So if I write it like this, 2 into 2 into 2 into 3, right? This is 8 into 3, 24. So I have written 24 into its prime factorization, right? Now if I combine the powers of 2, I can write it like 2 raised to power 3 into 3, right? So a composite number can always be factorized in prime factors, right? And the fundamental theorem of arithmetic says that these factors, this prime factorization is always unique. What I mean is that 24 can always be factorized in prime factors like this, 2 into 2 into 2 into 3. This is the only factorization possible in terms of its prime factors of 24. You can change the order, you can write it like this. You can write 2 into 2 into 3 into 2, right? By changing the order, you cannot change its constituents or its factors, right? There will always be 2 into 2, 3 2's and 1 3, right, multiplied with each other. So order you can change, 2 into 3 into 2 into 2, right? Even the order will be fixed. If I say that you should write these factors, let us say I say in ascending powers, okay, in ascending order. So you write the first smallest prime first and then go on to bigger primes. So the order is also fixed now. 2 into 2 into 3 is the only order possible if I write the primes in ascending order, right? Even if I say write in descending order, even then the order will be fixed. So this is about fundamental theorem of arithmetic, that a composite number can be factorized in prime factors. We should write a composite number can always be factorized, right? It can always be factorized in prime factors, and the factorization is unique apart from the order in which it is written. Right? Let us check other composite numbers, some of the composite numbers, and then see. Let us say we take 26. 26 can be factorized into 2 into 13, right? So these are the only factors of 26. These are the only prime factors of 26, right? 1 and 26 are the factors of 26, that is a given thing. But if you talk about prime factors, 2 and 13 are the prime factors of 26, and this 26 can be written as 13 into 2 or 2 into 3, right? Order I have changed, but the prime factorization is unique. You can take bigger numbers, and this will verify in case of bigger numbers also. 120 can be written as, what are the factors of 120? 120's factors are 2 into 2 into 2, 8, then 3 into 5, right? 8 into 3 is 24, 24 into 5 is 120. So this is the prime factorization of 120, right? Now you can write this in compact form by writing 2 into 2 into 2, like 2 raised to power 3 into 3 into 5. So this is the factorization of 120, and this is a unique factorization. And you should notice that there is a 0 in the end of 120, right? For a 0 to be in the end of any number, we need 5 and 2 as its factors, right? If there is 1 0 in the end of a number, that means there is at least 1 5 and 1 2 in its factors, right? If I remove this 5 from it, what will be the number? 8 into 3, 24, right? If I remove 2 from it and do not remove 5, then 15 into 2, 30 into 2, 60. I would remove all 3 2's, then the 0 will not be there, right? So to form a 0 in the end, if I remove 1 2, right? Let us say 2 into 2 into 2 into 3 into 5. If I remove this 2, even then a 0 will be produced, because now I have got 1 5 and at least 1 2, right? If I remove this 2 also, then 5 into 3, 15 into 2, 30. Even then there is a 0. If I remove this 0 also, 5 into 3, 15. Now I cannot have a 0 in the end, right? What I am trying to say here is, let us take another number and talk about it. For example, if I take 2 into 3 into 3 into 5. Now if I ask you how many zeros will be there in the end of this number, right? Just by looking at the pair of 5 and 2, how many pairs of 5 and 2 are there? Only one pair, right? So there will be 1 0 in the end, because 5 into 2 is 10, right? So this is responsible for producing the 0 in the end of a number. So what will be this number? 2 into 9 is 18 into 5, 90, right? So there is 1 0, and this 0 is because of this pair of factors 2 and 5, right? If I remove this 2 from here, what will be the number? 5 into 3, 15 into 3, 45. 0 cannot be produced without a factor pair of 5 into 2. This is what I am trying to say here. I hope this concept is clear. Now we can always write a number in terms of a factor tree. For example, if I take a number 32760, right, and if I try to factorize it, first of all, this is an even number, so let me divide it by 2. Okay, so what will be the quotient? 16380, right? Now again I can divide, I can write these numbers like this. Now again I can divide this number by 2 because this is still an even number, right? So if I divide this number again by 2, I can write 16380 like 2 into 8190, right? So I am making a tree of the factors. 32760 is nothing but 2 into this number 16380. 16380 is nothing but 2 into 8190. Now I will factorize 8190, and this is an even number, so I will divide it by 2. So 2 into, it can be written as 4095, right? Now it is an odd number, but we see a 5 in the end, so let's divide it by 5. First of all, let's check for the next prime. After 2 we have got next prime as 3, so let's check for the divisibility of 3. How do you check for the divisibility of 3? We add all the digits. 9 plus 5 is 14, 14 plus 4 is 18. So yes, this number is divisible by 3, so we can divide it by 3. And it won't be wrong if you divide it by 5 and then divide it by 3, but let's go in ascending order. Let's divide it by 3. 1, 3, 6, 5, right? Now again let's check for the divisibility of 3. 1, 3, 4, 6, 10 plus 5, 15. Yes, it is divisible by 3. So let's divide it by 3 again. 4, 5, 5, right? Now if you check the sum of digits, 4 plus 5, 9 plus 5, 14, it is not divisible by 3. So the next prime is 5, and yes, it is divisible by 5 because the last digit you see is 5, right? So let's divide it by 5. If you divide this number by 5, you will get 5 9s are 45, 91, right? So the next prime here is 7. So let's divide it by 7 and you will get 13, right? So this is the prime factorization of 32760. 32760 can be prime factorized into factors 2 into 2, how many times? 3 times. 2 into 2 into 2, and how many 3s? 3 into 3. Then 5 into 7 into 13. So this is the prime factorization of this number 32,760, and this prime factorization is unique apart from the order. You can write 13 before 7 or 5 before 3, right? It won't make a change in this product, right? Okay, now if you write it in compact form, you can write it like this: 2 cubed, 3 squared, 5 into 7 into 13, right? So every composite number for that matter can always be written in terms of its prime factors, right? Product of its prime factors, and that prime factorization is always unique apart from the order in which it is written. For example, if you have got 2 cube 3 squared, right? So you can write it as 2 square into 2 into 3 square, right? If you have got 2 cubed and 3 squared, you can write it 3 squared into 2 cubed, or 2 into 2 into 3 into 2 into 3, right? You can keep on changing the order, but you can never change the composition, that there will always be power of 2 as 3 and power of 3 will always be 2. In this composition, power of 3 will always be 2, power of 2 will always be 3 in this number, right? You cannot change that fact. But yes, while writing, you can write it as 2 is into 2 into 3 into 2 into 3, or 2 into 2 into 2 into 3, and you can write 1 3 here, right? You can change the order. So this is one thing. And the other thing that we learnt is that in any number, if there is a 0 in the end, we need a pair of 2 and 5, at least one pair. You may have more than one 2's, right? In this case, how many zeros will be there in the end? Obviously 1 0, because we have got one pair of 5 and 2. Even if I have 4 2's here, even then we will have only 1 0 in the end, because the pair is 1. Pair of 2 and 5 is 1. So what is this number? This number is 80, right? So we have got only 1 0. Even if I multiply it by 2, I'll still have 1 0 in the end, right? But now you see, 2 into 2 into 2 into 2 into 5. If I multiply this number by 5, now how many zeros will be there? You see, we have got now two pairs of 2 and 5, right? So there will be 2 zeros in the end, produced by these two pairs. So this pair is producing 1 0 in the end. This pair is also producing 1 0 in the end, right? So this will be, how many 2's are there? 1 2 3 4 2's are there, right? And 2 5's are there. So this number will be 2 into 2 4, into 2 8, into 2 16, 5's are 80, into 5 400, right? Okay, so this number here that I have written is 400. So it has got 2 zeros in the end, right? So this is how we can do. This number is still 180, so I had to write 2 here, right? Because this was 80 and I multiplied it by 2 to make it 160. So I wanted to illustrate that if you have got only 1 5, so you can have only one pair of 5 and 2, right? So there will be only 1 0 in the end, okay? And I multiplied this number by 2, so this is that 2, and it made it 160, and still there is 1 0 in the end, right?